Hi everyone, welcome to CodeTav Management AI Engineering playlist series. So today actually we are continuing this linear regression practical part. So in the last lecture, I have given one example and shown the practical part one of this linear regression, and this is the part two. So here actually we will discuss these things with more realistic data set, and we will show some plottings, and we'll cover what is the MAE, MSE, RMSE, R2 scores. Okay, and how from those data the analysis actually will be done. And after that, like whenever the training has been completed, so with some unseen data, how the actual price is being calculated. So that actually I will show you. So first of all, I'm just showing you again, like in the last day, in the house price prediction part one. So there we had only two columns. One is area, another is price. So according to the area, the price was being calculated. But and on that day only we had approx 100 rows of data. And today I have collected a more brief data, you can say. Here we have approximately 500 data. So 500 rows of data, and we have more columns, not only area. We have bedrooms, bathrooms, parkings, age. Actually, the realistic way how the real estate's price has been calculated. So in that way, actually, I'm going to show you. So our model can predict according to those features like the area, bedrooms, bathrooms, parkings. So from that, actually, we will create one model, and we will store that in a pickle file, and whenever you want to use that, you can use that, and you can pass the unseen data, and you can get the result like the price. So here from initially, like in the last lecture also I've explained those parts, but in this lecture also I am just explaining like what we have imported. So first of all, import tells the Python to load an external library. Okay, so first of all, we have imported the pandas library. So pandas, that is one of the most popular libraries for handling the datasets. So we write as PD because PD is the sort alias. So instead of writing pandas.read CSV, we can write like pd.read CSV. So we can simply write pd.read CSV. That's the shorter and most accepted form of pandas. Next, we have imported the numpy as np. So now we are importing the numpy, and numpy is basically used for the numerical computations and mathematical operations. So almost every machine learning library internally uses like uh, numpy arrays because they are the first and memory efficient. Okay, so the alias np is the standard conversion, and we have imported the matplotlib.pyplot as plt. Okay, so matplotlib is basically a visualization library. The pyplot, basically that module helps us create graphs such as line charts, scatter plots, histograms, and bar charts. Okay, so we use the alias as PLT because it is shorter and widely accepted. And lastly, we have imported the job lib. So that basically helps us save the trained machine learning model to disk. So instead of training the model every time, we can save it once and load it whenever it will be needed. So this is how models are deployed in real world applications as well. So after that, we have like from the sklearn.model selection, we have imported the train test split. So that basically this function divides our dataset into training data and testing data. So training data teaches the model, and testing data checks how well the model performs on unseen data. Next is we have imported like from sklearn.linear model, we have imported the linear regression. So this basically imports the linear regression algorithm. So it contains the logic for finding the best fit straight line between input features and the target variable. Next, we have like from sklearn.metrics, we have imported the mean absolute error, mean squared error, okay, R2 score, okay. So like these are the evaluation metrics, okay. So mean absolute error basically calculates the average prediction error, okay. Then mean squared error basically squares the errors before averaging them, so giving more weight to larger mistakes, okay. Then is R2 square, R2 score. So that is basically tells us how well the model explains the variation in the data. Next, we have done the df equals to pd dot read csv and house price part 2 dot csv. So this pd dot read csv basically reads the csv files and loads it into the pandas data frame. So the data frame is stored in the variable df, where df stands for data frame, right? So next is we have done the df dot head. So uh, head functions, you know, that displays the first 5 rows of the data. You can also see like 0 to 4 here, the 5 rows we got. So this basically helps us quickly verify that the data set loaded correctly, and lets us inspect the column names and sample values. Next is x equals to df, then these features, and y equals to df price. So X contains the input features. So these columns describe the characteristics of each house, the area, bedrooms, bathrooms, parking spaces, age of the house. Okay. So the model will use these features to learn how to predict the house price. And Y equals to DF price. So Y is the target variable. This is the value we want the model to predict. So in this case, that is the house price. Okay. Next is like x train test, x test, y test equals to train test split, x comma y test size is 0.2, random state is 42. Okay, so train test split, that function basically divides the data set into training and testing the sets. Okay, so X contains the features, Y contains the target values, and we have kept the test size equals to 0.2. So that means 20% of the data will be reserved for the testing. And random state we have kept as 42. So that means like that ensures the split is reproducible. Okay, so we get the same training and testing sets each time we run the notebook. Okay, next is like model equals to linear regression function. So that line basically creates an instance or object of the linear regression class. So at this point basically the model is created but has not learned anything yet. Okay, after that model dot fit x train and y train. So that fit function is basically where the actual learning happens. So the algorithm analyzes the training data and calculates the coefficients, okay, and intercept that produce the best fit linear equation. Okay. After that, pred equals to model dot predict x test. So predict function basically uses the trained model to estimate house prices for the testing datasets. Okay, so that basically uses the trend model. So before estimating any house prices, okay, for testing the datasets. So the predicted values are stored in the variable pred. Next, we are actually printing something. Okay, so here we have printed the MAE, MSE, RMSE. Okay, those things. So MAE is basically the mean absolute error. So this basically calculates the mean absolute error, means the average absolute difference between the actual and uh, predicted prices. Okay, so if it will be low, like if lower MAE, that means the better performance. After that, MAC means the mean squared error. So that calculates the mean squared error because the errors are squared. before averaging. So if there will be like larger mistakes, so that will be a greater impact on the final value. And RMSE, like the root mean squared error. So that basically simply the square root of MAC. So since RMAC has the same unit as the target variable price, so it is often easier to interpret than MAC. Okay, so like after that R2 score. So R2 means like R2 means the R square score, you can say. So that measures how well the model explains the variation in the target values. So if your R2 score is more close to 1, that indicates an excellent fit. If it will be more close to 0, that indicates poor predictive performance. For our case it is 0.989, it is very much close to 1, so our case is like excellent fit. Okay, after that residual. So a residual basically calculates the like the difference between the actual value and the predicted value. So residuals basically helps you to analyze like where the model is making errors. So we have also plotted the thing, so that basically creates a scatter plot, you can say. Like so that like this creates a scatter plot of predicted values versus the residuals. So a good model should have residuals randomly scattered. For our case also, there is no pattern, it's randomly scattered. Okay, so that is a very clear pattern, like no clear pattern is there. So like for our case it is very good fit. Okay, after that what we have done, we have drawn one horizontal line at 0. So it basically serves as a reference line, so we can easily see whether residuals are above or below 0. Okay, so here you can see all are like above 0. That's why like we have the 0.98. Okay, okay, cool. So after that what we have done, we have dumping the pickle file, like that basically this ninth one. So that basically saves the trained model to a file named this linear regression model pickle file. Okay, so saving the model allows us to reuse it later without retraining. Wherever we will need, we will just import it. So in that way, at line number 10 we have done the job dot load, we have loaded that pickle file. Okay, so we have like this loads the saved model back into memory. So the loaded model behaves exactly like the original trained model. So then what we are doing, we are predicting the price of a new house with these features, like area as the 2500 square feet, bedrooms as 4, after that bathrooms 3, parking 2, age 5 years. So the model uses everything it learned during training to estimate the price of this new house, and then we get the result, like that can be the price. Okay, so I hope you got the things what I want to share. So if you have any questions you can comment below. Okay, I am happy to answer actually, and we will continue our sessions in the next lecture. Thank you everyone. Don't forget to like, share, and subscribe CodeTab Management, as actually that motivates me to create such more technical videos. Okay, thanks everyone. Bye.